everyone, welcome back to the 5-Minute Tech channel. Today we will be talking about how to architect asynchronous microservices, what is it about and how we can go ahead and implement it in our system. So let's get started. So why asynchronous microservices? Why do we need it? We need it because we need to avoid temporal coupling, in the sense like we have multiple service calls one after the other and it takes time for it to complete, and that leads to time consumption on rendering it to the client. We also need to overcome the chained synchronous calls, and for that purpose we need to have asynchronous microservices. So if you see, there are multiple services. Each of these services are taking time to respond to the client, and that results in a latency. So by doing asynchronous microservices, you can avoid that latency and be more responsive to the client request. How to implement asynchronous microservices is to implement something like a fire and forget, which has no delayed responses or no long running jobs running in the backend, and we decouple the client and services and have a perceived performance. So how we will do it is, we have some service like, for example, a shopping cart, which is taking time, and then what we do is we completely decouple the server side with the client side, give a perceived response, and when the actual response comes in, we will be transferring that data back to the client. The asynchronous microservices can be achieved through two approaches. One is async API approach, where all you do is you go ahead and make your API asynchronous. So we'll first see the async API approach and then move on to the event-based approach. In the async API approach, we do an immediate or default response to the client. So as soon as the client is sending a request, we handle the incoming request and we pass it to the responsible service, which is the account service, which handles the incoming request with a callback info. Async callback task, we configure that, and background task, and then we do a complete the task and update the status using callback. In the meantime, the API gateway or backend for front end returns an acknowledgement, and then when the status is updated using callback, the send notification happens, and then the actual response is sent back to the client as a notification. So one thing important to note is the client and server is completely decoupled in this case. The client can continue to do other processes, whereas it doesn't need to keep waiting for the response to come back. And also the API gateway or backend for front end is also decoupled from the other services, and it can continue to call other services, and in turn when there is a callback request, then that is when it gets the data. The other approach is the event-based approach, in which we have three ways of doing it. First is our simple event-based, using our message broker, which could be in the form of RabbitMQ or Kafka or any other message broker in that sense. So what happens when the request comes from the client, the gateway passes it to any service, and that service passes it to a message broker. The message broker relays the request to the responsible services, like order service, and when the acknowledgement comes back, that is updated to the client. So that way the client is free to do other activities by the time the processing happens, the order processing happens, and as soon as the processing is completed, the client is notified. The next is the work queue pattern, which is more used, in which it helps in supporting services with multiple instances. We can use as a load sharing among the service instances. We increase the resiliency, and the asynchronous message exchange can be achieved with the scaling microservices. We can have multiple shopping cart microservice, another multiple product microservices, and each of these can subscribe to a particular queue, can connect to a particular queue, get the data, and they can be in a queued manner. The data can be passed to each of these services, and when everything is done, that notification can be sent back to the client that the entire processing is completed. Next is publish and subscribe pattern. All event / message can be consumed by many services, wherein we have to pass to multiple services that request, and all data changes are raised as an event. One action or transaction is composed of multiple tasks, wherein multiple services are called to do the action, and different microservices types can asynchronously do the task. For example, here create an order is a particular is a task which is composed of multiple tasks like creating cart order, updating product list, applying discount, and updating the order history. All of this, as soon as you do a create order, this is sent as to the message broker, and the message broker creates all these events of doing all these specific actions, and the individual services are notified, or individual services picks up those actions or events to be consumed and then processed, and the data has to be processed and then sends back a response as soon as it is done to the client. So this is the publish and subscribe pattern. So now we saw 4 ways of doing asynchronous microservices. First is API, API, and then there are 3 different event-based approaches through which you can achieve asynchronous microservices. That will be all for this video. Hope you like this video. If you like, do press like and subscribe to the channel. Have a nice day.